Hey, this is Joseph Burnett. I'd like to explain to you a little bit about how we do Mac runner autoscaling on AWS. There's a little bit more to it than autoscaling Linux. There's a few more layers of abstraction. So I wanted to just kind of walk through it with kind of a concrete visualization. I can also put it in text and make a diagram, but I thought it'd be kind of helpful to see what the life of a job looks like on AWS M1 Max. So my audience here is engineers who kind of want to see what the big pieces are, someone who wants to understand how the architecture affects cost, or anyone else that's kind of interested in how to efficiently run GitLab jobs on AWS Max. So let's start off with GitLab Runner. So GitLab Runner is executing on an instance somewhere. In this case, it's a GC instance. It's just a process running there. It could be anywhere. It connects to GitLab.com, pulls down jobs, and gets execution environments and injects those jobs into them. It's pretty much the standard way that GitLab Runner works. We put it in alongside our other runners just because it's easiest to have it in the same infrastructure, in the same cloud provider. There's a difference, though. This version of GitLab Runner is using a new framework called Task-Scaler. Now, Task-Scaler is our primary autoscaler. It's aware of machines and capacity. It's aware of concurrency within those machines. It implements the algorithm, the standard GitLab Runner algorithm, which responds to new jobs, creates instances on demand, and also has an idle configuration allowing you to maintain extra capacity. This is the future of GitLab Runner autoscaling. This is how we're going to replace Docker machine. And as part of that, in order to abstract away the cloud provider, we use a plugin system. So there's an out of process, there's a separate process which runs and provides access to some cloud provider through a common abstraction called the instance group. So when Task-Scaler wants an instance in which to execute a job, it actually just asks the fleeting plugin, hey, give me another instance, or give me the connection info for the instance of my choice. And it will create additional instances that way too in order to maintain the idle capacity. So this is the fleeting plugin mechanism. And so, of course, the fleeting plugin takes the instance group calls and translates them into an auto-scaling group. In AWS, groups of machines, groups of instances that are the same are managed in an auto-scaling group. And it stamps them out sort of 1, 2, 3, all exactly the same. You ask for 3, it gives you 3, you turn it up to 4, it creates another one, all off of a launch template. So this is great. This is how Linux autoscaling works and how it will work. But there's a little bit more to Macs in AWS. One of the requirements of a Mac is that it needs to be on its own dedicated host. So these instances, rather than just getting thrown up there on common hardware, you actually have to put each one of these instances on a dedicated host. And those hosts need to be created as a separate resource. So there's something called a host resource group here, which manages creating and deleting hosts in response to instances created by the autoscaling group. So the Task-Scaler here is our primary autoscaler, which scales the instances by job load and in order to maintain capacity. The host resource group is another autoscaler whose only job is to scale in and out the dedicated hosts in response to demand for instances from the autoscaling group. So there's a few other caveats with running Macs on AWS. Some of these come actually from the Apple's user agreement. Some of them come from just limitations in the performance at this point in time. So it takes about, after you create an instance and it gets scheduled onto a dedicated host, it takes about 30 minutes for that instance to boot up and be ready. A second limit, so that's actually quite a bit of time. You don't really want to create an instance in response to a job that's waiting. You want to be able to schedule that job on a running instance within less than a minute, for sure. Another slowdown is when that instance is removed, that dedicated host needs to spend 40 minutes scrubbing all of the data off of that before another instance can be rescheduled. So you lose that capacity for 4 minutes when an instance disappears. The other limitation, which is based on the end user agreement, is once you created a dedicated host, you actually need to keep it for a minimum of 24 hours. So even if you remove all the VMs, you have to keep them around for at least 24 hours. So that also kind of cuts into cost a little bit. So the last limitation to be aware of, and the one which leads to this next layer of indirection, is there's Apple doesn't allow more than 2 VMs to be on a single host. So let me explain why this matters. If you put a job here in this instance and you run a job here, it's gonna have complete control of that execution environment. It's gonna put files everywhere. It's gonna do stuff. So when you remove the job, you have to delete the instance. Well, because it's so slow, we don't want to actually delete the instances after every job. So we put each job inside of a nested VM. Okay, so these nested VMs are actually fairly fast to spin up. The image is already pre-baked into the AMI. You just spin up the VM. As soon as the job is done, you delete the VM along with it. Now, Apple limits you to 2. So we will put 2 jobs, up to 2 jobs on each of these instances, 2 nested VMs. But that's all. So there can be a couple different flavors based on different, OS, like about different tool chains, but they're all just baked in here and they come and go pretty quickly. So that's the level of isolation that we provide, is nested virtualization inside these Macs. So I want to talk to you a little bit about now that you see what all the pieces are, I want to show you what the life of a job is. So let's say we get a couple of jobs over here in GitLab that want to be executed on a Mac. One of these jobs arrives here. So let's pretend like this doesn't exist yet. One of these jobs arrives here. It's routed to this execution to this executor, which is using Task-Scaler, and Task-Scaler says, okay, you want an execution environment. Great. It uses AWS Fleeting plugin to find out what all of the instances are. It picks one of them, let's say, this one here, and it assigns, of the 2 VMs that you can run on each instance, it assigns slot 0 and 1. So when it comes back to the runner, Task-Scaler says, use this VM slot 0. So then GitLab runner moves along here, and it actually uses a library called nesting to create the nested VM. So here's a little client and a server, which is running on the instance. So each one of these instances has a nesting server running on it. And its only job is to sort of manage the life cycle of those nested VMs. So GitLab runner will then say, okay, I have been assigned a instance and a slot. So I can now tell nesting, create this VM, this image, use this image to create an execution environment on this and in slot 0. So nesting will say, okay, slot 0 sounds good. It'll create this. So, and then GitLab runner will SSH into the VM itself and put the job inside the nested VM, like so. So this is sort of how it manages. It has an agent inside the instance. And likewise, another job shows up. It will choose slot 0 in this other, in the same instance. That's okay. It'll SSH in, create the VM. Then it'll SSH in to the nested VM, and it'll run the job itself. Likewise, the rest of the capacity could get consumed by additional jobs. They get routed here. Then Task-Scaler says, well, actually, I really want to maintain, a certain number of idle machines. So it's going to create, when it schedules these, it's going to create another instance to get ahead of the demand. And so auto scaling group, it'll say AWS Fleet and Plugin, please create me one more instance. The auto scaling group will create the instance. Host resource group will respond to that by creating a dedicated host. Instance will get scheduled on there. It will boot. Once it's done booting, it'll have the nesting server running and it's ready to go. Likewise, when Task Scaler sees that we don't need all this capacity anymore, maybe most of the jobs are finished, it could say, okay, I think I'm done with this instance. So it'll tell AWS Fleet plugin, delete this instance. Auto scaling group will delete that specific instance. Host resource group will notice that it'll start scrubbing this will start a scrubbing process. Host resource group will see that this thing is unused for 24 hours and will eventually remove it. So that's the gist of it. That's the whole life cycle of auto scaling jobs on AWS Max. I hope this was informative and sufficiently visual and colorful. And I'll write this up also as some text and a diagram if that's your preferred way to consume it. So thanks for watching. I appreciate you taking a few minutes to learn more about Autoscaling Max.